All right, root 2 sine of 3x plus pi on 4 plus 1 equals 0, and we're looking for the general solution for this. So let's rearrange this so that we have sine of 3x plus pi on 4 is equal to negative 1 on root 2. Now, when I see a solution as such, I need to have a look at what's happening in my unit circle. And sine is negative, as we saw in the example above, in quadrants 3 and 4. And my base angle is going to be pi on 4. Okay, so this is the starting point for what we're doing here now. So let's have a look when we go round and round. So we start at 0, and in our first revolution we're going to have pi plus pi on 4, and we're going to have 2 pi minus pi on 4. Next time we go around, we're going to have 3 pi plus pi on 4 and 4 pi minus. So this looks a little bit like the previous example where we had even and odd solutions. But let's have a look at how we're going to put those together. So we've got 2 solutions in each revolution. So what we've got is our angle. Now be careful, because our angle is actually this whole thing inside our brackets. So we're going to have to do a little bit of algebra afterwards. So 3x plus pi on 4 is going to be, okay, we've got pi plus pi on 4, 2 pi minus pi on 4, 4 pi minus pi on 4, and we can see we've again got this odd, even, odd, even pattern developing. And to get an odd number, I'm going to say 2n plus 1 times pi, and even numbers are 2n times pi. So I can say, therefore, 3x plus pi on 4 is going to be 2n plus 1 pi plus pi on 4 minus pi on 4, when n is an integer. All right, but now we're not looking for 3x plus pi on 4. We're actually just looking for x. So what we're going to need to do now to start with is first subtract pi on 4 from every single term on the right-hand side. So therefore, 3x is going to be 2n plus 1 pi plus pi on 4, and I'm going to subtract pi on 4, or it's 2n pi minus pi on 4 minus pi on 4, where n is an integer. Okay, before I divide, I'm just going to tidy that up. So 3x is 2n plus 1 pi, plus pi on 4 minus pi on 4 cancel each other out, and 2n pi and minus 2 pi on 4 becomes pi on 2, where n is an integer. And then I'm going to divide all of them by 3. So x is equal to 2n plus 1 pi over 3 and 2n pi over 3 minus pi over 6, where n is an integer, and we can make that a lowest or a single, this one here, the second one, we can combine those two fractions just to tidy it up a little bit. So 2n plus 1 pi over 3, and this one can go over 6, so it becomes 4n pi minus pi over 6, where n is an integer, and I can tidy that up a little bit more as well, because I can take out or factorize out a common pi. So 2n plus 1 pi over 3 and 4n minus 1 pi over 6. And that z looks like an r. It's not an r, it is an integer.